Okay, Assalamualaikum warahmatullahi wabarakatuh. Today I want to present my material about subject research methodology. Before that, I want to introduce myself. My name is Rafly Ramadan and I come from 5BD class, State Polytechnic of Sriwijaya, majoring in English Department major. Okay, today I want to present about the sampling. First, types of probability sampling. First, simple random sampling. Second, systematic sampling. Third, stratified sampling, cluster sampling, and the last but not the least, multi-stage sampling. Sampling. Sampling is defined as the procedure to select a sample from individual or from a large group of population for certain kind of research purpose. There are different advantages and disadvantages of sampling. We will be thinking sometimes that why there is a need of sampling. The answer is as it's too expensive and time consuming to survey a whole population in a research study. Probability sampling. Probability sampling. In this type of sampling, there is a known probability of each member of the population of being selected in the sample. When population is highly homogeneous, there are high chances of each member of being selected in a sample. For example, in a bag full of rice, if we want to pick some rice, there are high chances of each rice grain of being selected in a sample. Hence, the sample collected will be a representative of the whole rice bag. Simple random sampling. What is simple random sample? A simple random sample is a subset of statistical population in which each member of the subset has an equal probability of being chosen. A simple random sample is meant to be an unbiased representation of a group. An example of simple random sample would be the names of 25 employees being chosen out of a hat from a company of 250 employees. In this case, the population is all 250 employees and the sample is random because each employee has an equal chance of being chosen. Random sampling is used in science to conduct randomized control tests or for blinded experiments. Advantage of simple random samples. This obviously represents the biggest advantage of simple random sampling, unlike more complicated sampling methods, such as a stratified random sampling and probability sampling. No need exists to divide the population into subpopulation or take any other additional steps before selecting members of the population at random. A simple random sample is meant to be an unbiased representation of a group. It's considered a fair way to select a sample from a larger population since every member of the population has an equal chance of getting selected. Although simple random sampling is intended to be an unbiased approach to surveying, sample selection bias can occur when a sample set of the larger population is not inclusive enough, representative of the full population is skewed, and require additional sampling techniques. And disadvantage of simple random samples. A sampling error can occur with the simple random sample if the sample doesn't end up accurately reflecting to the population is supposed to represent. For example, in our sample random sample, 25 employees, it would be possible to draw 25 men even if the population consists of 125 women and 125 men. For this reason, simple random sampling is more commonly used when the researchers know little about the population. If the research know more, it will be better to use different sampling techniques, such as a stratified random sampling, which help to account for the difference within a population, such as age, race, or gender. Other disadvantages include the fact that for sampling from large population, the process can be time-consuming and costly compared to the other methods. Okay, the next, systematic sampling. Systematic sampling is a type of probability sampling methods in which sample members from a larger population are selected according to a random starting point but with a fixed periodic interval or the sampling interval. Because of its simplicity, systematic sampling is popular with research. Other advantages of this methodology include eliminating the phenomenon of cluster selection and low probability of contaminating data. Disadvantages include over or underrepresentation of particular patterns and a greater risk of data manipulation. Example of systematic sampling. As a hypothetical example of systematic sampling, assume that in a population of 10,000 people, a statistician selects every 100% for sampling. The sampling intervals can be systematic, such as choosing a new sample to draw every 12 hours. As another example, if you want to select a random group of 1,000 people from a population of 50,000 using systematic sampling, all the potential participants must be placed in a list and starting point will be selected. Once the list is formed, every 50 person on the list or starting the count as selected start point will be chosen as participant, since 50,000 per 1,000 as 50. For example, if the selected starting point was 20, the 17 person on the list will be chosen followed by 120 and so on. Once the end of the list was reached and if additional participants are required, the count loops of beginning of the list to finish the count, systematic sampling versus cluster sampling. Systematic sampling and cluster sampling differ in how they pull same points from the population, include in the sample. Cluster sampling breaks the population down into clusters, while systematic sampling uses fixed intervals from the larger population to create the sample. Systematic sampling selects a random starting point from the population and then a sample is taken from regular fixed intervals of population depending on its size. Cluster sampling divides the population into clusters and takes a random sample from each cluster. Stratified sampling. Stratified sampling is where the population is divided into strata or subgroups and random sample is taken from each subgroup. A subgroup is natural set of items. Subgroups might be based on company size, gender, or occupation, to name but a few. Stratified sampling is often used where there is a great deal of variation within a population. Its purpose is to ensure that every stratum is adequately represented. Cluster sampling. Cluster sampling is sampling plan used when mutually homogeneous yet internally heterogeneous groupings are evident in statistical population. It is often used in marketing research. In this sampling plan, the total population is divided into this group, known as cluster, and simple random sample of the group is selected. The elements in each cluster are then sampled. Given elements in each sample cluster are sampled. Then is referred to an one-stage cluster sampling plan. If a sample random subsample of elements is selected within each of this group, this is referred to stage cluster sampling plan. A common motivation for cluster sampling plan is to reduce the total number of interview and cost given the desired accuracy. For fixed sample size, the expected random error is smaller when most of the variation in the population is present internally within the groups and not between the groups. Multi-stage sampling. As the name suggests, it contains many stages and hence called multi-stage sampling. In this, each cluster of sample is further divided into smaller clusters, and the members are selected from a smaller cluster randomly. It's a complex form of cluster sampling. Natural groups in population selected as cluster. Each cluster is divided into small clusters, and then, from the small cluster, members are selected randomly. Okay, I think it's enough for my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.